Okay, so before we get into the details of converging lens, let's look at the two types of lenses and a little detail about these two lenses. First up is a converging lens, okay? And the second one is a diverging lens. Converging lens, the basic description of a converging lens is that it is thicker at the center, okay? And it's thinner at the edges. For example, like this. This is a converging lens, okay? And if you draw an imaginary line from the center of this lens like this point is known as C, which is optical center. And then there's a principal axis, a line that passes through the optical center is known as a principal axis. And this principal axis will have focal points, one focal point on this side and one focal point on this side, right? Because object is placed on one side and image is created on the other side. This is why there are two focal points. Okay, then there's a diverging lens. Diverging lens is thicker at the edges and thinner at the center. So if you want to look at the diagram, it will be something like this. Similarly, it's also going to have one optical center over here. And then there's going to be a principal axis passing through the, it has to pass through the optical center like this. This is the principal axis. And the principal axis would again have a focal point on one side and the other focal point on the other side. Okay. So these are the characteristics of converging and diverging lens. These lens, because they're different, this is why the images that they're going to produce will also be different. Converging lens will produce a different type of image, whereas diverging lens will produce a different type of image. We're looking at the image diagrams now. So converging lens first up. For a converging lens, what you need to do is the first thing is to have this lens. Let's assume that this is your lens, okay? And this lens is gonna have one principal axis first of all, okay? So I'm gonna draw this line. Yes, this is the principal axis. The principal axis has to pass through the optical center. So we're assuming that the imaginary line on over here, for the optical center, this is the line. It's supposed to be a dotted line, but anyways, so this is C, the optical center, okay? And this is your principal axis. Now what you're supposed to do is, assuming that the object is placed on this side of the lens over here, this is the height of the object, okay? And one of the focal points, so what we can do is, the next ray will be produced from the object, the top of the object to the center of the lens like this. And then it will pass through the focal. So there's gonna be focal point, one focal point over here, and then another focal point on this side. Remember, focal points have the same distance, the focal lengths. The distance from the center, for example, if this is your lens here, so distance from the center, optical center to the focal point is known as small f, which is focal length. So focal length on left-hand side and the right-hand side will be the same. Now the next line is that from the center, the line passes through the F, the focal point, like this. Yes, it's just gonna go on. yeah, we forgot one very important line that has to be the starting point. First one, line that has to pass through the center. This one. This is very important. This has to be your first line, okay? So if you extend both of these lines now, this one as well. So they're gonna meet at a point, right? Assuming, I'm just gonna extend it like this. Assuming they meet over here. And then the third line will be from the top of the object to the passing through the first focal point like this. Like this. And then it's gonna pass straight through. So because this it's not drawn to scale, so it has to technically, all of these lines have to technically meet at this point, assuming this is the point where all of these lines meet. Okay, I'm just gonna draw these again. So because the meeting point has to be the same, okay? So we're just assuming that this is where all of these lines meet like this, okay? Hold on. Yeah, so this is a common meeting point. When you draw these three lines, this is your first line, this is your second line, and this is your third line, okay? These are called rays. And the point where all of these rays meet is the image with a downwards arrow. This is your image. So how would you describe this image? That the image produced by a converging lens, it is real and it is inverted. Why it is real? Because this image can be displayed on a screen, and it's inverted because of the direction of this image. All right. This was the first case of a converging lens. The second case of a converging lens is similarly, you have a lens. You've got a principal focus, okay? Sorry, principal axis like this. And this is the C, this optical center. Now, the object is, you see, this is your focal point, and this is your other focal point. So what we're assuming here is that the object is placed between the center and the focal point this time, like this. Yeah. In the first case, the object was placed behind the focal point. If you call it case one, in case one, object was behind focal point. And in the second one, in case number two, the object is between focal point and the optical center, F and C. So now what's going to happen here is the first line is going to be the same, the line that passes from the object's top to the optical center like this. And you're just going to extend it in all the directions like this. The second line is the one that passes from the object's top. Again, if let's say this is your center of the lens, line's going to pass from the object's top to the center, and it will pass through the focal point like this. But you will have to, because the lines are not meeting at this point, right? On the right side of the lens, there's no meeting point because lines are diverging. So because this is a convex lens, converging lens, the lines will meet at this, at the left-hand side now. So if you extend the second line like this, you'll get a meeting point. And then if you connect the meeting point with the principal axis, this is your image. Now the difference here is that the image is on the same side of the object and it's upright. So how would you describe this image? Number one, this is a virtual image. And it is also upright. Virtual because this image cannot be displayed on screens, and it's upright because you look at the direction, it's in the same direction as the object. So this is how you draw the diagrams for converging lens. Now, if we look at the diverging lens, the diagrams of a diverging lens. Just a quick recap again, a diverging lens looks like this. It is thicker at the edges and thinner at the center. And diverging lens are where the rays, they don't really meet, okay? They diverge from a point. So let's look at this diagram. There's one diagram for it. First up, you've got this lens like this. There is a principal axis. And you've got one focal point over here, F, and one focal point over here, F. Okay. So we're saying that this is where the object is. So the first, and this is the center of the lens, optical center here. First ray would be the same. From the object stop to the center, like this. The second ray, however, would now move from the top of the object to the center like this. But it's not gonna move on to the right side, the focal point on the right side, but instead it's gonna cross the focal point to the left side like this. I'm just gonna draw it and dot it. And if you extend it, so it's gonna go like this. If you extend this line, right? So now, if you see, this is the meeting point, and if you draw a line over here like this, the image is created on this side. And then you can maybe complete the leftover lines. One of them could go like this, other one could join this point over here, but that's not necessary. But you've gotten the image, right? This is important. So this image over here that's created on the same side and as part of a diverging lens, you see it's a smaller image. So image is always virtual. This is the property of a diverging lens image. It is virtual, it is diminished because it's small, right? And it is also upright. So these are the properties or characteristics of the image formed as a result of rays passing through a diverging lens.